Welcome to Year 2 A-Level Maths Pure Module. This chapter will be looking into binomial expansion, which is a continuous chapter from Year 1, where you've learned about how to expand using binomial formula, Pascal triangle. So it's fairly a short chapter. However, you do expect nearly every one question per exam year because this is slightly different. It's like a harder version of what you learn in Year 1. Okay. However, both versions, whether it's the year one binomial or the year two one, which is what you're going to learn in 4.1 to 4.3, could be tested. Okay, are examinable. Right. So let's do a bit of recap as we mentioned about year one binomial. All right. So expanding 1 plus x to the power of n. So recap. So are you able to write down Pascal triangle up to the fifth column? See if we can write down. So it'll be 1, 1, 2, 1. 1, 3, 3, 1. Just to remind you how it works, 1 and 1, 2, 1 sort of is something you have to remember. And then every row will start from 1, and then you add the previous two numbers, the numbers on top of each other, to make the number below. So 1 plus 3 gives you 4. So you're right in the middle to show that 1 plus 3 gives you 4 in the middle. Okay, 3 plus 3, 6. 3 plus 1, 4, and then you end with a 1. And the fifth row will be 1. 1 plus 4 is 5. 1, 5, 10. 10, 5, 1. So hopefully you do remember how to use it, which I will actually showcase later. So n factorial. So what does n factorial means? What does factorial means? Not exclamation mark, factorial. It means you're going to multiply all the previous term, all the previous integers up to n. Okay, from n all the way to 1. So it'll be n factorial means n times the previous term, n minus 1, times n minus 2, times n minus 3, dot, dot, all the way times 3, times 2, times 1. That's n factorial. Okay, so n choose r, which we use NCR, or we can write as NR, like this in the bracket. The definition is n factorial over r factorial times n minus r factorial, right? You rarely use this. However, actually, this will be useful for us to derive what we're going to learn in the chapter 4.1 in year 1, in year 2 binomial expansion. Right, n1. So what's n1? n1 means if we use the definition, it will be n factorial over r is 1 factorial times n minus 1 factorial, which if you expand this, this becomes n factorial. Or actually, I'll write, instead of n factorial, what I'll do is I'll write as n times n minus 1 factorial over 1 factorial. Put in a calculator, you get is 1. And then denominator is n minus 1 factorial. And then if you divide it, to simplify it, you get just n. Now, if you struggle to understand why can we write n factorial as n minus 1 factorial, just think of this one, okay? Think about this, all right? So if you have 5, let's say 5 factorial, 5 factorial is 5 times 4 times 3 times 2 times 1, right? Equally, what you can do is you can rewrite 5 factorial as 5 times 4 factorial because that's the same as 4 factorial. 4 times 3 times 2 times 1, that's 4 factorial. So you can write 5 times 4 factorial. That's the same thing in here. N, think of n being 5. 5 factorial, same as 5 times 4 factorial. Okay, right, n, choose 2, do the same thing. So let's try n factorial, 2 factorial times n minus 2 factorial. Now, how does that work? How can we simplify the n minus 2 factorial? Well, you can think about 5 factorial. I want a 3 factorial because think about n being 5. 5 minus 2 is 3. So I need a 3 factorial so I can simplify the numerator, a denominator rather. So it will be n times n minus 1 times n minus 2 factorial over 2 factorial times n minus 2 factorial. Then the n minus 2 cancel each other. So what does that give you? That gives you n times n minus 1 over 2 factorial. Now leave a 2 factorial, even though you might be thinking, oh, you're a bit extra. 2 times 2 factorial is the same as 2 times 1. Isn't that equals to 2? So 2 factorial is 2. Why do you keep the factorial? You will see. Coke and Pepsi are not the same. Just like 2 factorial, even though they look similar, but actually there's a reason why we keep it as a factorial. Actually, 2 factorial is the same as 2. So, but you can't argue Coke is the same as Pepsi. Just like McDonald's nuggets is the same as, not same as like Tesco, Sainsbury nuggets, you know. And 3, okay, and choose 3. So n factorial. Now, if you're confident, try this, okay? Try to derive this, see if you can get the same result as I do, okay? So 3 factorial, n minus 3 factorial, which is n times n minus 1 times n minus 2 times n minus 3 factorial over 3 factorial times n minus 3 factorial. Now, n minus 3 factorial can simplify each other. which give you n times n minus 1 times n minus 2 over 3 factorial. Now, one thing to note, okay, note n minus 1 factorial over n minus 1, you cannot cancel that way. You cannot, okay? Don't. You cannot, do not put it, that question, that's an exclamation mark. Anyway, it's not a factorial. So you cannot just cross out like that, okay? The reason being is n minus 1 factorial is the same as, think about 5 factorial divided by 5. You still have so many numbers behind. Let's say if you divide by 5 in here, right, on the other side, you still have so many numbers behind it, so you cannot just simply get rid of the 5. Doesn't work like that. All right, so sort of on the side. Right, last one. Okay, if you're happy with this, try and choose 4. You might be able to do that yourself. You should be. Okay. Oops, spoiler. You saw what's coming up next. Joking. If you have a notes, you would have seen. If you have the paper copy notes, if you don't have it, I suggest you print it out. It's in the description below. So 4 factorial over times n minus 4 factorial equals n times n minus 1 times n minus 2 times n minus 3 times n minus 4 factorial over 4 factorial times n minus 4 factorial. So cross it out. So you're left with n times n minus 1 times n minus 2 times n minus 3. Actually, you know what? Speaking of which, this is not a recap, I realize. But anyway, it's just a recap of using how to use a definition again. Okay. So what can we see? As we choose a bigger number from n, you can see on the numerator, we're getting more terms from n. There are n in each row. And then we get n minus 1. We're adding an extra term in the n choose 2. N minus 1, n minus 1, and then n minus 2, we're adding n minus 2 into choose 3, but we're also adding n minus 3 into choose 4. That's the numerator. We can see each term, we're getting more brackets, an extra bracket. What about denominator? Denominator is, you can imagine that's a 1 factorial. If you would like 1 factorial, 2 factorial, 3 factorial, 4 factorial, that's why we don't simplify it, so we can see a pattern. Okay, sometimes it's not the simplest version is the best. Okay, keep it raw, keep it natural is a good thing. All right, 2 factorial, 3 factorial, 4 factorial. Okay, and you can imagine n choose 5 will have 5 factorial. Right, so anyway, we'll actually come back to this in a bit after this expansion. Now, have a go, okay, expanding this bracket in here. I do have a way to write it out nicely and neatly for you to check how you can expand binomial expansion with whole number. This is what year 1 you've learned, okay, feel free to have a go. But if you want to listen to my way, I will go through the left one and you can try to apply it to the right one. Okay, right example. So what I'll do is, now we know 1 plus x to the power 5, we start with 5 choose 0, right? 5 choose 0. And the first term is 1, the next term f to the power 5, x to the power 0. Now what I do is, normally some teachers teach you right across. Where I teach it is, I teach you right underneath. 5 choose 0 to 5 choose 1. 1 to the power 4, x to the power 1. Now the good thing about this is that you can actually see, you can actually check line by line, because 0, 1, 2, you get 3, 4, 5. The 1 remains the same, but the power goes down by 5, 4, 3, 2, 1. And the power of x goes from 0, 1, 2. Remember, the power, when you add them up, it should give you back to the whole, to the max, to the power is the same as you expanding. 5, 3 will be 1 choose 2, x to the power of 3. And then 5, 4, 1 to the power of 1. X to the power of 4, and 5, 5, 1 to the power of 0, x to the power of 5. So again, you got a whole nice list of numbers, by the way, we're all adding. 0, 1, 2, 3, 4, 5. 5, 4, 3, 2, 1, 0. 0, 1, 2, 3, 4, 5. That's how we know we're definitely correct in this kind of working up. Okay, then what we'll do is I'll put in a calculator one by one. 5 choose 0 times 1 is 1. 5 choose 1 times 1 to the power of 4 is 5. Don't forget the x. This one, put a calculator, is 10 x squared, 10x cubed, 5x to the power 4, and x to the power 5. Well, to be honest, if you knew it better, you would have known this 1, 5, 10, 10, 5, 1 is exactly the Pascal triangle role. So these two are interchangeable. Okay. Is Pascal triangle useful? Perhaps, maybe for the up to the power of 3 when you have to do it manually. But however, I tend to use a calculator. Okay, so my final answer, don't forget to write the final answer, x to the power 5 equals to 1. You simply add up the numbers on the right side. 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the power 4 plus x to the power 5. That's expansion. Right? If you want to ever go this one using the method or whichever way you prefer, if you still prefer whatever your teacher is teaching you, feel free. Okay, pause video, have a go at this question. When you're ready for the answer, you can press play. Well, here are the final answers. Just be careful of the plus and minus. When you put a minus, make sure you put in bracket because it's negative 3x. So in the x position, make sure you put a 3 minus 3, x, put in bracket. So when you square it, cube it, whatever, you don't forget the negative 3. Okay, that's the answer. Hopefully you don't have any issue with that. If you do have it, go back to year 1 binomial expansion videos. Okay, right, so now let's go to the real deal for year 2 stuff after yapping for so long. Right, notes. When the power n, okay, of a binomial expansion is a fraction or a negative number. So in year 2, we're looking into expanding with a fractional power or negative power. We can use this version of binomial expansion. So we can have, so actually this also given the formula booklet, 1 plus x to the power of n equals to, actually roughly equals to technically, 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 over 3 factorial x cubed plus dot dot dot. Now, does this look really familiar? Yes, these are the coefficients from what we derived earlier. N choose 1, n choose 0, n choose 1, n choose 2, n choose 3, right? But do you have to remember it? Not really, because these are all given in the formula booklet. So it is given in the formula booklet. Okay. So the expansion is valid when the modulus of x is less than 1. So this modulus of x is less than 1. So that this expansion is a converging series. Now, why you're thinking, you just learned in chapter 3. Now, why you might be thinking, why does it have to be a converging series for it to be valid? I mean, what I'm trying to say in here is, why does this value of x has to be less than 1 so that this has become valid? Why? Why does it have to do with converging? The reason is because, okay, if you're interested, you can write down. Okay, reason that it needs to be converging is because the sum will add to a to a certain number. E.g., okay, because as each term is smaller than its previous term as x increases. So for example, okay, so e.g., 1 plus 0.5 plus 0.25 plus 0.125. Hopefully you can use your chapter 3 knowledge about series and sequences to work out the sum to infinity. Okay, will equal to, so 1 plus sum to infinity equal to plus dot 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 equals to a over 1 plus r, a over 1 plus r, no? Or a over 1 minus r, so a over 1 minus r. The ratio is we multiply by 0.5 each time, so which is 2. That means this series will add up to 2. Okay, so that's how we know. Okay, that's why binomial expansion has to be a converging series, because otherwise it won't add up to a number. If you do 1 plus 2 plus 4 plus 8 plus 16 plus 25 plus 32, etc., you will never add up to a number. That's why it's important that this value of x will be less than 1. We'll actually investigate a little bit more as the lesson go in the second part of the lesson here. Right, example. Actually, in this example, we actually explore the validity. Anyway, use the binomial expansion for the find the first 4 terms of 1 over 1 plus x and state a range of values of x for it to be valid. Right, so we can write as 1 over 1 plus x as 1 plus x to the power of minus 1. Okay, so this is where we use the formula. Okay, so we can use the formula. So 1 plus x to the power of minus 1. Let me copy and paste the formula. So I've copy and pasted. I've copy and pasted the formula actually from the formula booklet. You can see it's a plus b to the power of n. So this version may, whether you're familiar to it or not, is basically what they gave you in the exam. So that's why remembering this actually is a useful one. So I've put it down here, but this one is not. Again, this version you have to remember yourself. Anyway, so we can use this. So how do we use this? Well, now we can see the n is equals to minus 1. N is a power, right? So we can apply the formula. So let's apply the formula. The question wants us to find the first four terms. So the first term would be 1 plus nx. N is minus 1. X is x. Plus n times n minus 1. So actually, I find it now a bit out of the way. So 1 plus nx plus n times n minus 1 over 2 factorial times x squared plus n times n minus 1. Sorry, n minus 1 is n minus 2. Sorry, it's minus 2. N minus 1 minus 2 is minus 3. 3 factorial over x cubed. So now you can put in the calculator, okay, one by one. If you know how, you should be able to find your factorial button in the calculator. If you don't, you can just do 2 times 1, right? So put in a calculator, it'll be 1 minus x. This one here, this fraction should simplify into just 1. So plus x squared. This will be minus 1 minus x cubed. Okay, right. So that's answer for part A. State the range of possible values of x to be valid. So for it is valid when the modulus of x is less than 1. By the way, if you don't know what modulus of x less than 1 means, okay, simply it means modulus. Modulus means the plus and minus version. You've learned chapter 2 about modulus function. So modulus means a positive negative. So what it means is this one you can rewrite like this. That means 1 has to be between 1 and minus 1. All right, alternatively. Now, if you try to put in numbers, if you try to think about, try to put numbers bigger than 1. If you try to put numbers bigger than 1 in here, what you realize is this will becomes, well, think about S2, maybe x, any number bigger than 1. When you square this or cube a number bigger than 1, it will only get bigger and bigger and bigger. However, if you square or cube a number that is smaller than 1, between minus 1 and 1, a decimal number 0.5 that is smaller than 1, between 1 and minus 1, actually each term will actually get smaller and smaller. And as we mentioned about converging series, that's why. Okay. In the exam, usually it will be a 1 mark or 2 marker at the end, right? So be careful with that. Right, example practice. If you're confident in what I just taught you, you can have a go at this one, okay? But if you're not, I'll go through, okay, with you as an example. So what I'll do is I'll rewrite 1 minus 3x to the power of a half, right? So now what I want you to write down is the value of x in here is minus 3x because the x term, the x represent everything after the 1. The n will be a half. Okay, so let's apply the formula. So that roughly equals to, remember this is just an approximation, 1 plus n, so n is a half, of x. X is minus 3x, plus n, a half, times n minus 1. Now I tend to write a half minus 1 rather than do it in my head of minus a half because I'm trying to lessen my cognitive load. So what I'm doing is in here is I'm just trying to follow the formula. If I try to do many things in my brain, chances are you're going to make a mistake, and you don't want to make silly mistake by just a simple process like this. Okay, I think you'll be beating yourself up for this, and no nuggets for the rest of the life. Over 2 factorial, x squared minus 3x squared. The first 4 terms, I need one more. N a half times n minus 1 times n minus 2 over 3 factorial times minus 3x to the power of 3. Now, what I'll do is, let me show you my calculator. What I'll do. Right, so this is what I'll do. Well, I can't do anything with 1, so I just write 1. A half times minus 3 over 2x. And then, in here, I just type in what I see. Okay, as a fraction, a half times a half minus 1, make sure you put a bracket, a half minus 1, over 2 factorial. I just put 2 because I know 2 factorial is just 2. Times, now on the side, I'll put minus 3 squared, which is minus 9 over 8. Okay, then that way it's fail-proof. Next one, fraction, 0.5 times 0.5 minus 1 as long as you put in calculator correctly, obviously. Minus 0.5, minus 2. So you're not doing anything in your head. Just do it, trust your calculator. 3 factorial. So 3 factorial is just 3 times 2 times 1. And then bracket, minus 3 cubed. Minus 3 cubed. Minus 27 over 16. And then x cubed. Oh, I forgot x squared in here. Okay. Right. So what are the silly mistakes a lot of students make? Well, one, either they do it mentally in their head and they made a silly mistake in there. So and they try to put a minus, let's say for example, if they did a half instead of minus a half, then they get a wrong sign. In here, they made a silly mistake on a half minus 2, etc. So that's one silly mistake. Second silly mistake, they forgot to put a bracket around the minus 3x. That's the second mistake. All right, silly mistake. Third silly mistake. They forgot the x squared, like what I just did. Okay, x squared and x cubed. Right. So and yeah, right. So I do want to write down. So see, these are 3 silly mistakes you make. They did math wrong. They forgot to include the factorial sign. So either like what I do 3 times 2, or they just use a factorial sign, or forgot to include the power of x. Right. State the range of values for x to be valid. So validity. Okay. So it is valid when the modulus x, right, less than 1. Now it's not x, it's minus 3x. And we know modulus means we can just make the minus disappear. So it'll just be modulus 3x less than 1. If we take the 3 out, 3 modulus of x less than 1, so x is less than a third. That's the validity. Okay, so you can, once you do a lot of questions, you can just rewrite x is less than a third. You don't have to show all the previous working out. So let me explain again. The x value is less than 1. The modulus makes a negative disappear because negative does not matter. In a modulus makes every negative positive. What a happy symbol. And then you can take the 3 out, factorize the 3 out, divide by 3. That's how you get it. Okay, right. So quick 5 examples for the validity if you struggle with validity. Okay, so just validity. So question A, it will be the modulus 4x is less than 1. Therefore, 4 modulus x less than 1, the modulus of x is less than a quarter. That's a validity. Okay. If you want to do it, you can pause video and do part B and part C. All right. So part B, it will be modulus of minus 2x less than 1. So 2 modulus of x less than 1, x is less than a half. And part C has to be 2/3 of x less than 1. 2/3 of modulus of x is less than 1. So modulus of x is less than 3/2. Because when divide over, it's a reciprocal. Okay, so the power does not really matter. Well, you only do this when the power is negative or fractional. Okay, so here we go. Example, find expansion of the square root of 1 minus 2x up to and including the term x cubed. What I want you to do is have a go at question A. Okay, your turn. Okay, have a go at question A. Pause the video, have a go. When you're ready for the answer, you can press play. Well, here's the answer. It's fairly straightforward. Okay, 3 marks. All right. So hopefully there's no issue. If you do check it term by term, if you order terms in here correct, make sure that means you put the calculator incorrectly, which is also a very common silly mistake. Okay. You think putting a calculator is simple, but actually it's not. Of all the dreams that you had as a primary school child, thinking, oh, if I get a calculator, I can solve every single maths problem. Boom. Welcome to reality, society, adulthood. There's no such thing. All right, welcome to A-level maths. Part B, by substituting, okay, x equals 0.01, find an approximation of root 2. Now, what I would do in here is I would rewrite the left-hand side, right-hand side. Let me write left-hand side, okay, of expansion. Now, I'm going to use the original function. Square root 1 minus 2x is roughly equals to 1 minus x minus a half x squared minus a half x cubed. Now this step is very important because it allows you, trust me, just put it right down. You will see similar question again and again. So having the left hand side and right hand side are equally important. By substituting x equals 0.01, we're substituting both sides. Okay, let's substitute x equals 0.01. So square root 1 minus 2 times 0.01 roughly equals to 1 minus 0.01 minus a half times 0.01 squared minus a half times 0.01 cubed. Okay, so what I want to do is I want you to put in the calculator both end, right? Put on both sides. Now, if you put on both sides, you realize the left-hand side, if you put in calculator, you should get 7 root 2 over 10. Okay, 7 root 2 over 10. And roughly equals, you put in the right-hand side, 1 minus 0.01 minus 0.5 times 0.01 squared minus 0.5 times 0.01 cubed, which is 0. We're going to copy all the display values. Now, a quicker way to put this in calculator is, okay, you can put 0.01 equal, and then, so your answer button is now the 0.01. They can do 1 minus answer minus a half answer squared minus a half answer cubed. It's slightly quicker, but we're always chasing for efficiency, especially, this is a common theme, especially students who like maths. Don't know why. Don't know why. Next, find approximation. I'll read the question. We've not actually answered the question yet. We want to find the approximation for root 2. So to find root 2, that means we want to make root 2 the subject. Okay, so I want to find, okay, to find the approximate value of root 2, we need to make root 2 the subject. Okay, we need to make, this is ugly. Make root 2, it's not any better. But anyway, make root 2 subject. So we times it by 10, okay, divide by 7. So 0.9899495 times 10 divided by 7 is 1.414213571. So what we're doing here is we times 10 divided by 7. Okay, and that's the answer. Okay, now this skill is quite a common thing, so make sure you learn it. Again, copy the question, substitute number they asked you to do both end, and then see what they need. Part C, without any further calculations, state how the accuracy of approximation can be found in part B, could be improved. So, simple, part C, okay, to improve the accuracy, we should include more terms in the binomial expansion. Right, so the more terms we've got in part A, the more accurate the final answer would be. All right, so I know, let's try one more. Now this one is slightly more different. So what's going on? Given f of x equals square root 1 plus x over 1 minus 5x. It's a comma. There's a comma, by the way. There's just a comma. Okay, it's not anything about approximate. It's not derivative, nothing. It's just a comma. All right, I should have put a space in between. Use binomial expansion to find up to and including x squared term. So, what's going on in here? So what we need to do is, I'm going to write 1 plus x, just rewrite the question, 1 is minus 5x. I can rewrite as power of a half, right? 1 plus x to the power of half over 1 minus 5x to the power of half. And what I can do, I don't write a half in denominator. I can write as 1 plus x to the power of half times 1 minus 5x to the power of negative a half. So then we have two expansion. So we have expansion 1, expansion 2. That's what I'm going to ask you to do. Okay, we have to apply the formula to each of expansion up to x squared term only. So 1 plus x to the power of a half. Okay, can you do that for me? Okay, and 1 minus 5x to the power of minus half. Okay, try that. Right, pause the video, have a go. Okay, expand up to x squared term. When you're ready for the answer, press play. Right, here are the answers, the two expansions. Okay, now what a question, we have not answered the question yet. We want to find the expansion of this. What do we have to do? We have to multiply two expansions together. Okay, so we have to multiply two expansions together. Therefore, okay, so 1 plus x to the power of a half times 1 minus 5x to the power of minus a half is roughly now equals to 1 plus a half x minus 1/8 of x minus 1/8 of x squared times 1 plus 5x plus 75 over x over 8x squared roughly equals to. Okay, now remember we only want the term up to x squared, so we don't have to multiply everything. Okay, so what we do is expand double bracket. So expand double bracket. 1 times 1 is 1. 1 times 5x is 5x. 1 times 75 over 8x squared is that one. A half x times 1, a half x. A half x times 5, that gives me 5 over 2x squared, still including, because we want up to x squared. A half x times this, however, we can ignore. We can ignore. Now, you can write it in here because it will give you x squared. We don't need, okay? Because that will give you x cubed. That symbol here means because x cubed we don't need, right? Next, minus the eighth x squared times 1. We love that. Minus eighth x squared. Minus the eighth times that. That gives you negative again. That gives you x squared. And that gives you x cubed. So we all ignore. Okay, so that's all we need. Okay, we only need up to x squared. So choose carefully, just like your friends. Um, right. Did I make a mistake? 5 over 5x. Oh, I made a mistake. Sorry, it's 5 over 2x. Sorry, it's 5 over 2x. 5 over 2, 5 over 2. That's 5 over 2. I'm fixing my answer. 5 over 4. Yep, that should be fine. Okay, so you should get 1 plus 3x plus 21 over 2 x squared. If you just collect like terms. Yep. Okay, let me just, I can't trust my mental maths. Let me try and can't trust my notes. Let me just do it again in the calculator. Yes, that's correct. Okay, and that's the answer. Okay, so when you have a composite function like this, split it up one by one, and then do negative power, expand double bracket, and then do that. Part B, state the range of values for that to be valid. So validity, okay, validity. So 1 plus x, we just look at bracket by bracket, is valid when modulus of x is less than 1. All right, so what about the second one? Then 1 minus 5x to the power of minus a half is valid when the modulus of minus 5x is less than 1, so the modulus of x is less than a fifth. Combining these two together in a number line, so 1 and minus 1. Okay, and then a fifth and a fifth and minus a fifth. So let me use the different color. So this is x less than a fifth. So 1/5 and minus a fifth. You can see where they overlap is simply this part. Therefore, square root 1 plus x over 1 minus 5x is valid when the modulus of x is less than a fifth, where both overlap. Okay, that's the answer. That's the overall validity. You have to combine both and see where they overlap. All right. So last one, I think is the last one, right? Yes, last one. Okay, it's a lot of learning this lesson because it helps set up for the next lesson and the following. But the next lesson, the rest of them won't be as long as this one. So exam practice. Pause the video, have a go at the question. As you can see, it's exam question. Chapter 4.1. 4.1 is exam question. Lucky you. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the final answers. Question A, I've showed you the expansion. Okay, if you got wrong, check it again, check it term by term. See if you, or put in calculator again. See if you made any silly mistake, just plug in the calculator. Make sure you have a bracket on. When you do negative 8x squared, ax cubed, or you might have made a silly mistake when you do the mental maths, or maybe you forgot the factorial thing. You have to do 3 times 2. Okay. For part B, what a weird question, isn't it? You might be thinking, how is that 2 marks? To be honest, I don't know. Actually, I have no idea why is this a 2 mark, because that calculator was a calculator paper as well. Anyway, I don't know why. It's a weird question. 2 marks, why not? You know, free gift. Part C. Now, part C didn't show my working out, but I should show you the final answer. If you got it right, well done. But if you got it wrong, I'm going to show you how. Okay, because this is a common part where students often forget how to do it. That's why I want to show you how to do it again. So what I want to do is, if you remember what I said, copy left hand side, right hand side. So copy left hand side, root 1 minus 8x. Right hand side was what you had in part A. Okay, sub in x equals 1 over 100, right? So when you sub in x equals 1 over 100, so 1 minus 8 times 1 over 100 roughly equals to 1 minus 4 times 1 over 100 minus 8 times 1 over 100 squared minus 32 times 1 over 100 cubed. So let me put the left hand side. So square root. I know actually in part, the left hand side is the answer of part B, but nevertheless, I'll put in calculator. You'll get root 23 over 5. right hand side. Now, if you want to speed up the process, you can put 1 over 100 in the calculator, press equal. Then that means you can use your answer button for every time you see 1 over 100. So I do 1 minus 4 times answer, minus 8 times answer squared, minus 32 times answer cubed, which gives me 0.959168. And now the question wants me to find the approximation of root 23. To make root 23 a subject, I would times it by 5. So that's how I get the answer. So times it by 5 in here. All right. And that's it for 4.1. It's a lot to learn. However, equally, you'll be questioned in exam. So nothing is wasted in terms of learning in here. Okay.